Welcome to the DIY Honda Garage channel. DTC P0010 indicates a malfunction of the variable valve timing control (VTC) oil control solenoid valve A in the Honda Accord 2023 and newer models. This issue arises when the return signal from the VTC oil control solenoid does not change as expected with the output signal from the powertrain control module (PCM). The PCM is responsible for monitoring various engine functions and responding to ensure proper performance, which includes managing the oil flow to the variable valve timing system. When a discrepancy is reported, the PCM logs this issue and triggers the check engine light, indicating a need for diagnostics. The VTC oil control solenoid valve is pivotal in regulating the timing of the engine valves, influencing engine performance, economy, and emissions. If this component fails, it can lead to various engine performance issues while driving, emphasizing the importance of timely troubleshooting. The variable valve timing control, VTC oil control solenoid valve A, is vital for managing engine operations, as it influences the timing of the engine valves to optimize performance. Located generally near the engine's cylinder head, it regulates oil flow based on the engine's operational demand. The powertrain control module, PCM, acts as the engine's brain, gathering input signals and controlling output signals to various components, including the VTC solenoid. Any failure in the signal exchange between the VTC valve and the PCM can trigger DTC P0010. Therefore, the malfunction could stem from the solenoid itself, the associated wiring and connectors, or potentially the PCM, which interprets the signals. Diagnosing the root cause requires careful inspection of these components, since each plays a critical role in the overall engine functionality. The causes of DTC P0010 primarily include a faulty VTC oil control solenoid, damaged wiring or connectors, and potential PCM malfunctions. A faulty solenoid may not open or close correctly, causing irregular oil flow for timing adjustments. Insulation wear or physical damage to the wiring could result in poor electrical signals that reach the solenoid or the PCM. Additionally, a malfunctioning PCM itself may incorrectly process the return signal from the VTC, leading to an abnormality being registered. Each of these factors is crucial to thoroughly check during diagnostics, as they contribute directly to the VTC system's ability to function correctly and maintain optimal engine performance. When DTC P0010 occurs, several symptoms may manifest, the most immediate being the illumination of the check engine light on the dashboard. This is a direct indication that a diagnostic trouble code has been logged by the PCM, necessitating a complete evaluation. Additionally, the driver may experience noticeable engine performance issues, including rough idling, reduced power during acceleration, and decreased fuel efficiency. Increased emissions might also be evident, as the vehicle fails to properly regulate valve timing. Each of these symptoms is critical to observe, as they guide technicians towards the underlying issue, thereby influencing the troubleshooting and repair process. The first step in troubleshooting DTC P0010 begins with starting the engine and holding the engine speed at 3,000 RPM without load. This test allows the engine to enter a working condition where the VTC oil control solenoid should be operational. It is crucial to hold the RPM steady until the radiator fan activates, indicating that the engine has reached sufficient temperature for diagnostics. Once the fan kicks in, the technician should set the Honda Diagnostic System (HDS) to the INVTC setting. This procedure enables the technician to observe real-time data concerning the variable valve timing functionality, specifically relating to the operative status of the oil control solenoid. Reviewing the VTC data at this stage is foundational in determining whether the component is functioning correctly. In this step, the technician needs to disconnect the VTC oil control solenoid valve A connector, which is typically a 2-pin 2P connector. This disconnection allows for safe inspection of the internal valve circuit. Following this, an ohm meter or multimeter should be used to check the resistance across the terminals. The expected value should range between 7.14 to 7.90 ohms at room temperature. If the reading falls outside this range, it suggests an internal issue with the VTC oil control solenoid, indicating that the circuit is possibly shorted or open. This step is significant as it directly points to potential failures within the solenoid itself and validates whether further inspection of the external circuit is necessary. For this troubleshooting step, the technician should disconnect the PCM connector to further investigate potential circuit failures. The VTC oil control solenoid valve A is connected to the PCM via two crucial signals, VTC in and the PG circuit. The inspection method involves checking the PG circuit and the VTC in circuit for continuity. Specifically, the technician should verify that both circuits show less than 1 ohm resistance in an open wire inspection. If the readings exceed this value, signs of a short or break in the wire may exist, indicating deficiencies in either the wiring harness or connector terminals. Addressing this step is crucial to ensuring the signals to the solenoid are clean and robust, ultimately allowing proper operation of the VTC functions. Continued inspection involves testing for any shorts to ground within the VTC-IN circuit. This step requires the technician to measure resistance between the control circuit and the vehicle ground. An acceptable resistance reading should exceed 1 mega-ohm. If the resistance is lower than this threshold, it implies that the wiring is compromised and creating a short to ground, which can severely affect the signals relayed to the PCM. This inspection step is paramount since it directly influences the operational reliability of the VTC system. Should any abnormalities be detected during this process, modifying or replacing damaged wiring will be necessary to restore normal function and signal integrity. The final troubleshooting step involves reevaluating the remaining components if previous tests indicate normal conditions. If prior steps indicate the VTC oil control solenoid and wiring are functioning correctly, yet DTC P0010 persists, it points to a potential PCM malfunction. Thus, the technician should assess the reliability of the PCM's performance by checking other diagnostic parameters and ensuring it processes all inputs correctly. If it is determined that the PCM is at fault, replacement or reprogramming may be required to rectify the issue. This concluding step reinforces the holistic approach to diagnostics, making sure that not only the immediate component is inspected, but also ensuring that the entire system functions cohesively. After completing all necessary repairs and replacements related to DTC P0010, a final verification process is crucial. To begin, the technician should clear any diagnostic trouble codes using the Honda diagnostic system. Once the DTCs are cleared, a test drive under varied driving conditions is essential to ensure that the repairs have rectified the underlying issues noted. Observing system responses and ensuring that the check engine light does not re-illuminate provides further confirmation of the repair's success. It's vital to keep detailed records of the performed inspections and repairs, ensuring transparency and enabling continuous vehicle performance monitoring. Conducting this final verification is key to confirming that the VTC system and its components are now operating effectively. Preventive maintenance is crucial for the longevity of the variable valve timing control system and to avoid future occurrences of DTC P0010. Technicians should recommend routine inspections of the VTC oil control solenoid and its related components, ensuring that any worn-out parts are addressed promptly. Regular checks of the wiring condition are also essential, as frays or other damage can lead to voltage drops or short circuits that may disrupt the entire system's performance. Additionally, keeping the PCM software updated and ensuring its electrical connections remain clean can vastly improve system reliability. Practicing these preventive measures can enhance vehicle performance and mitigate the risk of serious engine problems, allowing owners to prolong their Honda Accord's lifespan. In conclusion, understanding the intricacies of the VTC system and how the VTC oil control solenoid operates is crucial for effective troubleshooting of DTC P0010. By following a systematic approach to diagnose and repair, technicians can efficiently identify and remedy the issues affecting the vehicle's performance. The thorough evaluation of individual components, wiring, and the PCM ensures comprehensive diagnostics that lead to reliable repairs. Encouraging preventive care can significantly reduce the risk of future malfunction, promoting overall vehicle performance and longevity. Ultimately, staying proactive with maintenance and diagnostics cultivates an efficient and well-operating Honda Accord, aligning with the manufacturer's standards for excellence. Please like and subscribe to the channel. See you next time.